Algebra 2, Section 2.2, Part 1. I'm going to talk about functions, equations, lines, slope, point slope form today. First of all, a definition of a linear function. Actually, first of all, I want to remind you that there are a lot of applications for graphing in Algebra 2, and this section is one of those. So grab a few pieces of graph paper from my classroom, from my physical classroom in the back corner of the room if you like, or if it's too late for that, you'll need to print some off from my Google Classroom. Okay, linear function. A linear function is a function whose graph is a line. We defined what a function was in the previous section, and this is just one that has a line. Do you see the word line in the word linear? So it's just an adjective, linear, that uses the word line. It's like a line. And a linear equation then just represents a linear function. Let me give you an example. Sad though it may be, we will someday soon have snow on the ground. Let's hope for later, but it's coming. And let's suppose that there's 3 inches of snow on the ground, and then it starts snowing at a rate of a half an inch an hour, a constant rate of a half an inch an hour. This would be a linear function that could be represented by the linear equation. That is, if I use x and y, that is y equals 1/2 x plus 3. You see, because the plus 3 is already what's on the ground, and then 1/2 of an inch per hour, if I plug in the number of hours for x, I'll know how much snow is on the ground, right? The new snow would just fall on top of the old snow, and it would start to build up. Now, I know it packs down and that kind of thing, but I'm not talking about that, okay? Keep it simple. So, for example, at time 0, there's 3 inches of snow on the ground, right? Right when it starts snowing, there already was 3 inches. There's still 3 inches of snow. Like as if I plugged in a 0 here, 0 times a half is 0, plus 3 is 3, okay? But if I plug 1 in here, so how much snow will we have after 1 hour? Well, 1 times a half is a half, plus 3 would be 3.5, and that's what we would expect. If I plug a 2 in, there'd be 4. If I plugged a 4 in, there'd be 5, if it continued to snow at that constant rate. This equation represents that situation that I just gave you. Okay, now, along with that, I'd like to point out that x is the independent variable and y is the dependent variable. The amount of snow that's on the ground is dependent upon how much time has elapsed. Okay, with that, let's do this example. Graph y equals -4/3 x plus 2. Everybody should remember the good old, everybody's favorite t-chart. And we're going to pick values for x and then get outputs for y. Now think about this. What could you plug in here that would be a convenient thing to multiply a fraction that has a denominator of 3? See, I don't want to pick 1, because 1 times -4/3 is -4/3, and -4/3 plus 2 is a fraction, and then I'm stuck plotting a fraction that's not a place where the grid lines come together. If you can avoid that, you probably should. So what about 3? If I plug 3 in here, 3 will you kind of imagine that there's a 3 there for x. The 3 will cancel with the denominator of the 4/3, the -4/3. It's like 3 over 3. It's 1. So then you just have -4 plus 2. That would be -2. There's a point at 3, -2. What's another number? Well, everybody would like 0, wouldn't you? -4/3 times 0 is 0, plus 2 is 2. So how about 0, 2? Right and left, you go 0, and then up 2. Let's get one more just for fun. How about 6? Or -3 would be another popular choice. If I plug 6 in here, 6 over 3 is 2. That'd be -8, plus 2 is -6. There's a point at 6, -6. Now look at those 3 points. Are you convinced that it's a line? I mean, are we confident that we're going to graph the correct line? You should be. If you plot 3 points and they all lie on the same line, that ought to feel good. So I strongly urge you to draw long lines that span, long lines that span the graph. Okay, so don't just draw something that's really short. If at all possible, try to get it to cross both axes. Oh, it's black. I can't deal with that. Draw a nice long line that spans the graph, something like that. Use a straight edge, make it look nice. Take some pride in your work. Okay, so that's one example. Now, this is the same one we just did. There's what they did. How about this example? The equation 10x plus 5y equals 40 models how you can give 40 cents change if you have only dimes and nickels. The variable x is the number of dimes and y is the number of nickels. Graph the equation, describe the domain and range, explain what the x and y intercepts represent. Okay, that's a whole lot. Now, think about this. Think about it this way. How could you come up with combinations of dimes and nickels to get 40 cents? You could get 4 dimes. You could do 8 nickels. You could do a dime and 6 nickels, 2 dimes and 4 nickels, 3 dimes and 2 nickels. And I think that covers everything, doesn't it? I think there's really 5 different ways you could combine dimes and nickels to give 40 cents. All right. Now, with that, let me show you their graph and tell you why I don't like it. Okay. I just described for you 0 dimes, 8 nickels, 1 dime, 6 nickels, 2 dimes, 4 nickels, 3 dimes, 2 nickels, or 4 dimes, 0 nickels. Okay. Now, what they have here, I like the points, but they should have just left it at that. Don't do this dashed line thing. The dashed line is to suggest that this is not a continuous function, and it's not. But really, what would represent this accurately would be to just have these 5 points. The 5 points will do it. Okay. Now you know you're not going to have negative nickels or negative dimes. That's why we're in the first quadrant only. They didn't continue this way. They didn't continue into the fourth quadrant. Really, again, let me say it again. To correctly represent the dimes and nickels situation that was in this problem would be just these 5 points. Leave the dash line out. Okay, now let's make sure we answer all their questions. The variable x is the number of dimes. Graph the equation. You saw the graph. Describe the domain and range. The domain and range would be just the list of, for dimes. What did they say again? X is for dimes. So the domain for dimes would be 0, 1, 2, 3, 4. The domain for nickels would be 0, 2, 4, 6, 8. And then explain what the x and y intercepts represent. Well, that would simply be that it's when the other one is 0, right? And I'm going to talk about x and y intercepts now. Anyway. Now, by the way, let me show you one more thing. Look at their work here. You notice they plugged in a 0 for y, and then they solved for x. They got x equals 4. Plugged in a 0 for x and solved for y. What they're doing is finding the intercepts, and those were the first things that they then graphed. See, they got their red dot here, and then I have it covered up, but they have a red dot up there, and then they put the other points in. Okay? Now, x and y intercept. An x-intercept is simply where something crosses the x-axis. So I say something because we don't know if it's a function or just a relation. You saw examples of that in the last lesson. So it's where the relation, let's just say, crosses the x-axis. Could be multiple times. This will happen in Algebra 2 regularly. The y-intercept is where something crosses the y-axis. And again, if you saw in that last example, it is where the other variable is 0. You want to find an x-intercept, plug 0 in for y. You want to find a y-intercept, plug 0 in for x, and you'll find that'll help you to find the intercepts. Quick note about intercepts: I only need the number, right? To me, the y-intercept is identifying one of the variables at that point at 0. I only need the number. So if it crosses the y-axis at 5, the answer to what is the y-intercept is 5. If you want to give me the ordered pair, if it's the y-intercept and it's at 0, 5, that's fine as long as you do that correctly. If you choose to give me an ordered pair, don't switch them around. Don't say 5, 0 when you mean 0, 5. It would be safer to just say 5, because if you say something wrong, I have to mark you off for that. All right, so that's intercepts. Moving down then, look at the next thing, that's slope. You've probably heard of slope and rise over run, and you've probably seen this formula before. Well, that's where we are right now in Algebra 2 as well. And this is a calculation that'll get you rise over run. And the letter that's used is m. So we can calculate a slope by using this formula. Let me demonstrate. Find the slope of the line through the points -2, 7 and 8, -6. So that is a slope formula would be like this: y2 minus y1 over x2 minus x1. And I'm going to calculate that by going -6 minus 7. Now, there would be nothing wrong in the world for going 7 minus -6, minus -6, right? Minus negative, do you do what I do? Minus negative. Just change it to plus. But depending on which way you've done that determines which way you're going to do the bottom. You have to do it in the same way. So I went -6 minus 7 on the first one. I'm going to go 8 minus -2. This would be -13. Oops. -13/10. Okay. But if I had done it the other way, 7 minus -6, then that's fine. You just need to go first and then second, -2 minus 8, which would be 13 over -10, which is the fraction -13/10. And just leave it as a improper fraction like that. That's the way we like it, -13/10. Okay? Last little bit here. Point slope form. It's aptly named point slope form. The reason it's called that is because if you're given a point and a slope, you can just plug that into to this form and you'll have an equation that represents that. Okay? Or to say it the opposite, if you're given it in that form, you can pick out a point that you know is on the line and you can pick out the slope if it's in that form. Okay? M is the slope. Okay, this is the same M, right, as this M right here in point slope form. And x1, y1 is a point on the line, okay? So, for example, this problem says, right, now this says in standard form, and standard form is going to be in my next video. So the problems that are like this right now, that are in your homework, you can do them to the point that I'm going to do them right now. What you'll want to do is leave yourself a couple of lines after them. I believe there are 3 problems total. I think it's 20 through 25, and I think I assigned 3, 20 through 25 or 21 through 26, one of those, and I assigned 3 of those problems. So for those 3 problems, do them as much as I'm going to do them today, but then leave yourself like 2 more lines of paper for each of those problems because you'll go back and finish those after the next video. Write in standard form an equation of a line with slope 3 through the point -1, 5. See, it's very nice to have a a point slope form, because basically you're taking 3 and you're plugging it in right here. You're taking -1 and plugging it right here, and 5 right here. Okay. Now, note x and y are variables, and when we ask you for an equation, there should be 2 variables there. There should be an x and a y. Don't plug -1, 5 in for x and y. No, you want the x and y to remain. You want those variables to be there. x1, y1 is the point. So y minus 5 is equal to 3x minus -1. Do please always make that simplification of -2 plus. Y minus 5 equals 3 times x plus 1. That's point slope form. Now again, we will go further with this after the next video and turn this into what's known as standard form. That's the next lesson though. So you can stop here for now. Last one. Write in point slope form an equation of a line through 4, -3 and 5, -1. Now this isn't like the last one, because the last one they gave us a point in the slope. Now they're giving us 2 points. We can calculate a slope. -1 minus 3, minus -3, -1 minus -3 over 5 minus 4. That would be 2 over 1, or a slope of 2. Now, the question then becomes, which one should I pick? Which of the points should I pick? Answer is it doesn't matter, and I'm going to prove it to you right now. Y minus -3 equals 2 parenthesis x minus 4. Okay, that's one answer. Or y minus -1 equals 2x minus 5. Now these may look different to you. It said write it in point slope form. Either one of these answers would be fine. You would be done right now. What I'm going to show you last here is only for learning purposes. You're done once you've written one of these two equations. But look what happens if I distribute the two and subtract 3 from both sides. And look what happens here when I distribute the 2 and subtract 1 from both sides. These are identical. Okay? Now, let me just say one more time. None of this was required, and really only one equation or the other would have been fine. But I just wanted to prove to you that these, in fact, are the same equation by just doing a couple simple steps of algebra there. All right? Well, I think that's all. Yeah, thanks for tuning in. Bye now.